Question 9. This question is about olive oil. Samples of olive oil is mainly the unsaturated fat wire mixed with a small amount of inert impurity. We know Y's molecular formula C57H100O6 and what's that? Suitable target title for titration is this. This much of Br2 aqueous justify what much smaller target titer would not be appropriate. Well, a smaller titer will increase percentage uncertainty. Smaller titer will increase percentage uncertainty. Smaller titer will increase percentage uncertainty / error, and then calculate moles. We know moles. The concentration of volume, so it's going to be 30 divided by 1000, given here, times by 0.025. We divide 30 by 1000 to convert it to mole per dm minus cube, and we get 7.5 times by 10 to the power minus 4 moles. 9.2, 9.3, 9.4, 9.5. 9.2 says calculate a suitable mass of olive oil to transfer to the volumetric flask using answer to question 9.1 structure of Y. Well, we know Y to bromine. Well, if the bromine reacts with it, we're going to get Br2, 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 Br2 5 times. So we're going to get a 1 to 5 ratio if it does, when it does react, of Y to bromine. And we know the moles of bromine is this. So we want to find out the moles of Y. In this case, moles of oil. It's going to be 7.5 times by 10 to the power minus 4 divided by 5, which will give me 1.5 times by 10 to the power minus 4. And this is in, remember, this many moles of bromine is in 25 centimeters cubed. 0.025 mole per dm cubed times by 1000, 1, 2, 3, 25 centimeters cubed. We want it into the volumetric flask. Well, the volumetric flask contains 250 centimeters cubed, so we need to definitely times these moles by 10 in, and make sure why you're turning by 10. Tell the examiner because this is in 250 centimeters cubed. This is in 25, so we need 10 by 10 to get 250 centimeters cubed. So we get 1.5 times by 10 to the power minus 3 moles. And now we are close to getting the answer. We know moles equals mass over mR. Mass is equal to moles times mR. In this case, the moles 1.5 times by 10 to the power minus 3 times by mR, which is what does it say there? 880 times by 880, which will give me 1.32 grams of Y, right? And we know olive oil contains 85% of Y by mass. So all we need to do now is do this answer times by 100 divided by 85, which will give me 1.55, which is the final answer, 1.55 grams. And then 9.3 suggests an extra step to ensure that the mass of olive oil in the solution is recorded accurately. An extra step, it doesn't talk about weigh the bottle after the oil transfer. So weigh the bottle after oil transfer and record the mass. And why? Justification, not all of the oil is transferred. Oil is transferred. Or we can say, or to find the exact mass of oil used, not all of the oil is transferred, therefore we want to weigh the bottle after oil transfer to record the mass as justification, not all of the oil is transferred. And then state the reason for inverting the flask several times to ensure the solution is homogeneous. To ensure the solution is homogeneous, meaning that it's evenly mixed / distributed, but that's a really fancy word, and you can definitely use that to ensure the solution is homogeneous. That's what the mark scheme wants. Then it said reduce the molecular form of the compound. We know sample of olive oil dissolved methanol placed in mass spectrometer. The sample is ionized electrospray ionization. Each molecule gained a hydrogen ion H+ during ionization. The MZ value is 345. Therefore, the MR, because each one gained a hydrogen, we're just going to subtract 1, 345 minus 1, 344. And what we're trying to find is a molecular formula, and it's given us an empirical formula. So, because we know each molecule gained a H+, I'm going to subtract 1 to find the MR. And now let's find out the MR of this. C5H10O is going to be 12 times by 5, 60, 60 plus 10, 70, 70 plus 16, 86. MR 86 of C5H10O, and we know the MR should equal to 344 of this compound. So therefore what we need to do is 344 divided by 86, which should be a whole number, which is 4, and therefore we need to times this by 4 to get an MR of this. So times that by 4, we get a C20H40O4. C20H40O4, and that is the end of question 9.